All right, we're going to learn a bunch of vocabulary to allow us to talk about functions. So first of all, when you write f from a to b, we can say that is a function, or you could also say it is a map. Those basically mean the same thing. And we go from A to B. So we kind of have a source of elements, A, and source for inputs, and then we have a space in which the outputs are coming from as well. So those two sets, A and B, they have names. A is the domain, so that is an important vocab word here. And then B is called the codomain. You maybe thought I was going to say range, because in like other math classes you may think about domain and range, but that is not the correct terminology. It is domain and codomain. Now range we're going to define soon, so wait till the end of the video. We'll define what range is. So we got our domain and we have our codomain. Inputs come from the domain, outputs come from the codomain. Now when you say f of a equals b, a is the input, b is the output, but we can also say b is the what's called image of a. So b is the image of a, and a is a what's called pre-image. The pre-image of b. So the image of something is the image of something from the domain is what it gets mapped to. It's the output that you get from that thing. We call it the image. Now, if you look at not just one element of the domain, but like a whole subset of the domain, I'm just going to call that subset X. So capital X is some subset of our domain A. Okay, if X is a subset of domain A, then f of X, which seems like a little funny thing to do, because usually you think about putting an element in here, not a whole set of things. But this notation does have meaning. You can interpret this to mean the set of all elements B from the codomain, such that there exists an X in the set X with f of X equal to B. So basically, this is just representing the set of all things in the codomain that you get by feeding the function inputs from the subset X. All right? This is called the image of the subset X. Okay, so you can have the image of an individual element, which is going to be an individual element, or you can have the image of a subset of the domain, which will result in a subset of the codomain. All right, so now let's talk about the range. Now the range of f is basically the image of the entire domain. So if you imagine sticking all of the possible inputs into the function and then looking at all of the possible outputs, that's the range. The range is the set of all possible outputs. Now, you might think, well, how does that differ from the codomain? I'll show you a picture that kind of describes how that's different. Let's say this is our domain A. That circle represents our domain A. And over here, I'm going to draw a circle that represents our codomain B. The function f is a map that takes things from A and it corresponds them with things from B over here. So like if I have an element over here, let's call it lowercase a, the function takes that and it maps it to some element over here, which I'm going to call f of a, right? Now, if you look at all the things in A, if you stick all of those in the function, they're going to map over here. That's not necessarily going to give you all of the codomain. So inside here, you could have some subset, which is the range, f of capital A. That is the image of the entire domain. That's the range. But there could be things right in here, okay? There could be elements of the codomain B that are not in the range. They're not mapped to, so to speak. There's no pre-image for them, right? There's nothing over here that maps to something over here. So if you have an element like, let's call it like C sitting over here, maybe these elements have no pre-image. So like there is no x in A such that f of x equals c. Though that's possible, you can have things in the codomain that aren't in the range. So in the next video, I'll show you an example of a situation where that happens.